Hello and welcome to another episode of EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in sustainability, climate change, buildings, and urban efficiency. I'm Vic Marinich, Global Marketing Director for Danfoss, and I'm excited to be the host of this podcast. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever you get your podcasts. Today we have Ron Domitrovic from the Electric Power Research Institute, or EPRI, on the show to talk about heat pumps and their role in electrification. Ron is the program manager at EPRI, a nonprofit energy research, development, and deployment organization that works with industry and policy experts to ensure the public has access to electricity across the globe. Ron, it's an honor to have you on the show.
Thank you, Vic. It's an honor to be a part of it.
So to kick things off, maybe can you tell us a little bit about your background and how you got involved in energy research and electrification?
Sure. I've been in it for 30 some years now. It really goes back to my interest in construction. When I was in school, my interest was really in construction and building construction, and in particular in the infrastructure within buildings, so the electrical and the mechanical systems. And, sort of through that, I got introduced to the concept of heat pumps, and it was really the interesting thermodynamics of heat pumps and how they can, in theory, operate at above 100% efficiency that was intriguing, and it just led to a career in that field, and that career has spanned from the Oak Ridge National Lab is where I started, and then a couple other spots, and now for the last 13 years at EPRI.
You're quite a brave soul because I'll tell you, 30 years ago, heat pumps are not what they are today. So they were, I'm sure, very exciting times 30 years ago getting involved in heat pumps. So in your current role at EPRI, you work with really experts in the fields with academia, with industry, with government to drive technology advancement. Can you talk about what projects EPRI is currently working on, such as the Efficient Electrification Initiative?
Sure. So the electrification initiative started a number of years ago and has manifested into a whole research program and not just a research program, but it kind of has feathered into many of the research programs at EPRI. And so the idea of efficient electrification and electrification for the sake of decarbonization and productivity and so forth it's a major theme of what we do, certainly on the end use side of things. And that's an essential effort that we do that pervades really everything we do. Some of the listeners may have attended our electrification conference that occurred this past June and that we have on a 2-year cycle. So yeah, absolutely, it's an important part. There are multiple other, larger initiatives and then certainly focused projects that we do. Another one of interest might be the Low Carbon Resources Initiative, and that's an effort that looks at alternatives to fossil-based fuels that may feed into the power system. So things like hydrogen and so forth. And then sort of on a more focused level, we have a whole variety of projects looking at the application of heat pumps and related technologies for all manner of applications from window units, for instance, all the way up through large industrial systems.
Yeah, I guess most people think of their household heat pump when you think heat pumps, but really there's a lot of different applications we can have. And if you've been working with heat pumps for now pushing on 30 years, I guess you must certainly feel that now, right, the timing has really come for heat pumps. They've been maybe had not the best reputation 30 years ago, but now we're seeing so much focus on heat pumps with the green economy coming, with the issues we have in Europe. So now they've really come to the forefront.
Yeah, there's a lot in there. So it is interesting that, 30 years ago, and heck, even 10 years ago, heat pumps were a bit of a novelty. They were an important player, but a niche player. But all the while, people who worked in that field understood the nature of them and why they could be so effective and so efficient. And so it is interesting now to be someone who has been involved in it for years, and now to hear a lot of clamoring and a lot of talking about heat pumps and about their usefulness. The rest of those of us in the industry are all just patting ourselves on the back saying, well, yeah, I told you so. But yeah, it is an interesting time.
Right. I think we feel within the industry now that heat pumps are becoming, more and more popular. And like you said, I guess if once every 30 years we can pat ourselves on the back, then that's good for us. But how do you see the U.S. in general progressing towards this move towards electrification?
Well, I mean, I absolutely see it progressing that way for a variety of reasons. One, because the technology is just getting better. And so you're getting product that can satisfy customer requirements more effectively. And that's actually the most important part. And the secondary part is that there is policy that's driving that. There's policy that's restricting the use of fossil fuels, for instance, or incentivizing the use of electrically driven heat pumps. But none of that would be useful if the product couldn't satisfy the customer requirements for comfort, for cost effectiveness, etc. And that's what you see happening. And that's the manifestation of the research that's been going on for the last, several decades. And I would have to say, to me, the number one most important advancement among many in the heat pump technology over the last couple of decades is the incorporation of variable speed compressors. It's far and away the most important aspect that has allowed heat pumps to become useful across a wide range of applications.
You bring up a great point on really meeting the customer demand. I remember buying our first house just about probably 30 years ago, and it was down further south, and I wanted to put in a heat pump, and really no contractor was interested because they thought it was just going to be a nightmare on the service side. So we've come really a long way from contractors actively promoting not using a heat pump to now really where we see the market turning. So yeah, it is a great steps forward. So okay, so heat pumps, and you kind of briefly touched on there's a lot of different applications for where we have heat pumps, but what sectors do you see electrification having the biggest potential to help us meet the goals of the Paris Agreement and of reducing our carbon emissions?
So, the potential, I guess, would, really be kind of a function of how much energy is used currently in each of the sectors. And, residential, commercial, industrial are reasonably evenly split. And so then it comes down to what's the easiest to penetrate. And the residential and small commercial is probably the easier segments to penetrate because there's already a reasonable amount of technology and product out there in the residential space. All of the major manufacturers now make reasonably cold climate heat pumps that can, within reason, satisfy very effectively the heating and cooling requirements of a typical, American household. And same with rooftop units and so forth for small commercial. Where it gets more difficult is when the temperature lift is higher. And so where does that happen? That happens in commercial buildings that are hydronically heated, and maybe industrial processes where you have wider temperature gaps between a source and a process. And so there's still a lot of potential there in that there's a lot of fossil fuel used, but the technology is not as mature in those spaces. And that really comes down to what I mentioned, the temperature lift. So if you have to go from 10 degrees outside to 140 degrees Fahrenheit interior water temperature to circulate through a building, that's a higher lift than it is for an equivalent residence where you only have to get the indoor air up to, let's say, 110 degrees. So that's the technical challenge,
Mhm.
but very achievable, and it can certainly be overcome.
You hit a couple of the technical challenges. When we start to look now on other factors driving the move to heat pumps, we've seen a lot of stuff coming in the U.S. In the last year. We signed the Inflation Reduction Act. We signed on to the Kigali Amendment. So I think some very visible things happening, driving us that way. Do you see these efforts also pushing heat pumps, and do you think they'll help us get past maybe some of those other barriers, the non-technical ones, let's say?
I can't imagine it not doing that because if you're incentivizing with dollars and or restricting the use of fossil, for instance, then yeah, absolutely, it will drive the adoption of heat pumps. And exactly how is yet to be seen because I think there are some unknowns about exactly how funding would flow out of the IRA and how it would reach the customer exactly. But for sure, I think that will be a big driver. But there are other hurdles that you've kind of alluded to related to the knowledge of the installer, the willingness of the installer and the supplier to provide a heat pump. That's all changing, but on its own time scale. So, there is a lot of inertia in the business of installing gas furnaces, installing traditional types of equipment. And that slowly changes as people become familiar and as they become educated by manufacturers of more technologically advanced heat pump systems. And so we're seeing that change, but you can't force that too fast. It's not going to happen overnight. And so I think a little bit of patience is required because we absolutely see the sort of slow march toward heat pumps across all sectors and all applications.
So you touched a bit on, we talked about the technical aspects. I think heat pumps are getting more and more efficient, getting more and more reliable, the move to variable speed compressors. We have some legislative/financial incentives now moving. You touch a little bit on some of those other barriers that are maybe a bit more personal. You said that, adoption by the industry, by installers who've been doing things their way for so many years and so on. Of course, you kind of have to let the cycle happen, but what can we do to speed that cycle up even more?
To me, when the product is good, that's the best motivator for somebody to adopt it. And so you see that with things like the LED light systems that you see today. So when you go into a store and you go to buy light bulbs, you now see the filament style LED bulb. And until that became widespread and available, there was still a lot of hesitation to use, the old CFL bulbs or even the kind of, older versions of LED bulbs. And it wasn't until there was a really good product available that was truly better than the incandescent bulb that people really just said, yeah, I want that. That's the better product. And I'm willing to pay more money for it because it's better. And that will slowly happen with heat pumps as well, because in most cases, it is a better product. And I go back to what I was talking about, the variable speed systems, that technology, along with the ancillary parts that go with it, has really allowed heat pumps to provide better comfort in cooling, better dehumidification, better heating. And I think that's really going to be the driver. Now, the innovation and the creation of those products has been pushed ahead a little bit by various incentives and so forth, but that's how I see it progressing.
Mm-hmm. Maybe jumping back a bit on the technical side, do you see, is there a gap we still need to fill on the technical side to help get heat pumps that next step up?
There are maybe a couple on the larger system side that I see. So the ability to do air source heating in confined geography, so within cities, on large buildings, on skyscrapers and so forth, there's not a lot of product out that can do that yet. And then there's absolutely a need for development in the industrial space. Industrial tends to be a little less off the shelf and a little more custom. And so I think if things about the industrial space can be made more off the shelf, then I think there will be some more uptake. But there's very limited uptake in the industrial space right now with widespread heat pumps. And then on the residential small commercial side, it's really being able to handle all climates and all climates in a reasonably cost-effective way. And that, there's a lot of research going on in that area.
Right. Mm-hmm, mm-hmm. So, and we get back to the residential and the light commercial side of things. Here in the U.S., there's a good transition going towards heat pumps, but we've also got another transition to a next generation of refrigerants, right? Going to the low GWP refrigerants. Do you think that transition of refrigerants, has that helped or hurt the market's ability to increase heat pump utilization?
That's a great question. I don't know that I have a fantastic answer for that. It certainly makes it a challenge, but it has pushed some people to look at older refrigerants like ammonia and like carbon dioxide that are actually very good for certain situations. And I know there's a small project we're doing at EPRI looking at using ammonia as a refrigerant for chilling and for heating as well, but then using carbon dioxide as a distribution fluid. So think of a hydronic system that uses whatever, R134A with water. Now think of a system that uses ammonia as the refrigerant and CO2 as the distribution fluid. And so, it's causing people to think in different ways. And so that structure is kind of copied from what's done in supermarkets, and can it be applied to buildings as well? So I think it's definitely a challenge, but it's pushing people to think in different ways, which I think is advantageous.
Yeah, I think for the short term, I'm sure it's a challenge, right? Because there's only so much research and design and lab space and all those kinds of things out there. And now if you're trying to upgrade your systems to heat pumps, but then you also have a legislatively mandated refrigerant change, right? You've got to pick your priorities, and so maybe it becomes a bit of a challenge that way for sure.
Can I expand on that a little bit?
Of course.
I mean, I think you've hit on something that I do get concerned a bit, that as the sort of legislated requirements index up year after year, whether it's for efficiency or whether it's for refrigerant types and so forth, that occupies a lot of research time of the manufacturers and a lot of research budget. And that's not infinite. And so other things have to be put on the side while effort is put toward meeting those requirements. And so, if I had one beef about what's going on in the United States, it's that there's a limitation on the fundamental research in the space that's really been covered primarily by Japan and Europe. And I wish the US would get a little bit more involved in more fundamental work.
You're spot on there, because the market itself is pretty well saturated with all these changes going on there now. And you have to be successful next year, right, if you're going to invest into the long-term stuff. And when you have these legislative things coming and there's specific dates coming, that's kind of where the focus just has to be, right? I mean, we get it, but it does make it challenging for sure. It was interesting getting back to your topic of this ammonia system with distributed CO2, because I think as refrigerants, as the GWP continues to be driven down, a lot of these systems, I mean, you look at like a VRF, big distributed refrigerant systems, right? Supermarkets are already kind of there, right? They have to find ways to reduce that charge. And I think CO2 could be something pretty interesting. So I look forward to seeing what kind of results you guys get out of a system test like that. Yeah, that would be really interesting. Sticking on the refrigerant topic, we're so worried about 2024 and this next step down on the GWP, but not that far down the road, 2029, we're going to have an even further step down in the GWP requirements. So really a lot of the refrigerants that are coming out today, R32 and 454B and all those that are in that 750 and just below range may not make it right through the 2029 cut. So do you see any significant technology shifts that we're going to have to make in heat pumps to allow that next generation of refrigerants to be used?
Well, yes, some technology shifts, like, we were talking about some shift to the naturals like ammonia and CO2. But I'm also curious to see if there's more of a shift in the tolerance of allowing flammability, because that's where some of the other refrigerants like, propane and isobutane and so forth, and the A2Ls, those are valuable refrigerants, but they're limited in their volume currently. And so if we, collectively are more agreeable with higher volumes of flammable fluids in our homes and businesses and so forth, then I think that opens it up. If that doesn't happen, then yeah, I think it's very much a technical challenge to have systems that meet the GWP requirements, but also are usable refrigerants. I'm certainly not an expert in the chemistry side of that, but I know there's a lot of development from the refrigerant manufacturers.
Yeah, I think that next step today, it would really be a medium density kind of solution, it seems like, so 134A like, but we know what that would do to the size of heat exchangers, the size of systems in the US. To your point on propane, that's where the market's moving in Europe. We have a big presence there as Danfoss in Europe, and we see every heat pump manufacturing coming with R290 in their systems. Now, they're different heat pumps than what we have, right? They're air to water, water to water. They're not the air to air that we have. But I also see the US significantly limiting the allowable R290 charge, right? There's the global standard IEC 60335-2-40, which allows for certain charges of R290 in refrigeration air conditioning systems And it seems as of now, the US or the UL version of that is going to only take about 1/10 of that volume to make it allowable. So in the US, R290, at least as it stands now, is going to be quite a challenge. But I
Yeah.
guess we have till 2029 to figure it out, right?
Our tolerance tends to be lower. And what I'm curious about is over time, will our tolerance go up? Will there be enough data that says, we've had however, millions of these units in the field and we've had no incidents? Will they say, okay, well, then in that case, the tolerance can go up and the volume can go up? I don't know the answer to that, but that's what I'm thinking. Obviously, we drive around in cars that have flammable materials in them. We pipe flammable materials into our houses and so forth. So to me, it's really a question of the tolerance for it.
Yeah, as you said, right? We'll have many years of experience, at least in Europe, that we can look on when 2029 comes around. Okay, so getting maybe a bit away from the technical side, right? We talk about getting better heat pump adoption. Do you think there's something that manufacturers, suppliers, and so on can do to help promote the product to the end users?
Yeah, we've thought about this a lot. The joke was that in a house, the furnace and or the heat pump is thought of no differently than the 2x4 in the wall. It's just something that's there that doesn't have the glamour of the granite countertops or the tile bathroom. And so the thinking for a long time was, how do we do that? How do we make a heat pump, more exciting? And, I don't know that that's ever going to truly happen. But I think, the population is just more and more conscious of energy use and the results of that energy use. And so you capitalize on that. And when you educate people in bits and pieces to the degree possible and to the degree that they want to learn about it. And so, yeah, we've made some products. We have something called the Consumer's Guide to Heat Pumps that's really just meant to educate people. Maybe not everybody, but it's educating the people who are, for instance, at the front line. So, for instance, a utility staff who interfaces with their customer might use something like this. But those kind of products help to educate the population about, what a heat pump is and why it's useful and why it's worth paying attention to, and why you might want one in your next house.
So you'd already touched on variable speed, and maybe you could do a bit deeper dive there on why variable speed was such an important step in getting heat pumps to be more effective. And are there any other technologies maybe that you want to, a new heat pump, somebody new to heat pumps should know about?
Yeah, so variable speed, we could do a whole podcast just on that, but it's fundamental because it's just the ability to vary the flow of refrigerant, and it's that flow of refrigerant that enables heat transfer. And so it's that flow of refrigerant that allows you to take heat from a cold place, cold outside day, and put it into a warmer place, the inside. And just like the day has changing dynamics, the sun rises and it gets warmer, and then the sun goes down and it gets colder. So you need more and then less and then more again, heating capacity. And previously, before the advent of variable speed systems, we simply used single speed systems and we turned them on and off on some sort of duty cycle. And yeah, it worked. It was kind of a brute force way of making it work. And we've done that for decades. But the variable speed has unlocked incredible efficiency. So we'd have to get deeper into the weeds of the thermo as to why that happens. But effectively, at most conditions, you have very, very efficient operation when you're running at lower than maximum speed. So that's one benefit. But then the second benefit, and in heating, this is very important, is that when you can run the compressor and the fluid flow then faster in order to get more heating capacity out of a nominally sized system. And that's a lot of words, but what that means is that when it gets really cold, you can speed the system up and you can get more heat out of it. And that's really important. And that's very important for cold climate applications and for making heat pumps be perceived as a satisfactory system or as a good system by people for providing their heating requirements. Hopefully that made sense.
Yeah. So we've spent a lot talking about heat pumps, but they're really only one step towards the broader electrification picture. Can you maybe describe a bit how they fit into that bigger picture?
Sure. I mean, they're on the end use side of things. So if you're talking about electrification and decarbonization, which is the other side of that coin, it's a whole system approach. It really comes down to how do you use energy or a resource most judiciously. to achieve the things you want. And what do we want? We want comfort. And so, yeah, absolutely. The electrification of end uses with efficient electric devices allows for the use of a decarbonized grid or a decarbonized power generation system that, in concert with the end use, then produces the comfort that we desire, but with much lower energy use and energy consumed that is decarbonized. And then another aspect of that we really haven't touched on is the flexibility of electric loads. And so that when you go to decarbonize the power generation side, it's not the same way you used to do it. It might involve intermittent resources like solar and wind and maybe some storage to buffer that. But you also may need some buffering on the use side. So the idea that a heat pump or some other device like an electric vehicle could vary when it uses power and how much it uses at a given time is really important. And so that's happening as well. So you're seeing the electrification of the end use, you're seeing the decarbonization of the generation, and you're seeing the merger of the flexibility of the end use to complement what the generation side needs to produce. And so that's ongoing. That's kind of the evolution of the grid over the next, over the past 5 years and then probably the next 20 years.
So I was reading a report recently by the International Energy Agency, the IEA, and they were saying that to meet our 2030 decarbonization goals, that building energy intensity has to be reduced by 45%, right? So building energy intensity is the amount of energy used per square foot, right? So we need to be a lot more efficient. And of course, we have a massive building stock in the US alone. I think commercial buildings, there's about 6 million commercial buildings. So do you see retrofitting buildings with existing boilers, furnaces, whatever, and retrofitting them with heat pumps as an opportunity to reach this goal? And how realistic do you think all these retrofits are?
Well, I certainly think, yes, it is part of achieving that goal. Retrofitting existing buildings tends to be the more difficult option. Incorporating a heat pump system into a new build is easier because you can design it in and you can design insulation and the whole system around it. Retrofitting into an existing building, certainly possible. It's just a different engineering approach. And so you may not have the full suite of options that you have if you're doing a new build. And I mentioned a little bit about one of the major technical gaps that I see, and that's the ability to use air source heat pumps in large or tall buildings. And so if you tried to retrofit, for instance, New York City with all heat pumps, it's actually a very big technical challenge because of that. You don't have the room, you don't have the grid capacity, et cetera. So there are certainly technical challenges like that. But yeah, you can, if you want to retrofit an existing building with a heat pump, pretty much anywhere in the United States, you can do it. There is an engineering solution to do that. But it may or may not be the most cost-effective solution at this moment.
Mm-hmm. And would obviously take a bit of planning ahead of time, but certainly something to think about, especially if you're retrofitting, you're not doing it for a year or two, right? So even if maybe the capital expense isn't the lowest, where's natural gas going to be in 5 and 10 years down the road and that stuff if you decide to put in a boiler?
I think the deeper the retrofit, the more it makes sense. So if it's a superficial retrofit, it's maybe a little harder. But if you're gutting a building and redoing it completely, then it's much closer to a new build.
Yeah. Maybe one last question here for you. We've seen this big push for heat pumps coming from all different angles here in the U.S. How do you see this push for the heat pumps influencing innovation in the HVAC industry over the next 5 to 10 years? Where do you see the development needing to go?
Where do I see it needing to go, and what do I see happening? I'll try to address both of those. So
maybe both, yeah.
Yeah, I mean, needing to go is more of the same. Provide efficient systems that provide comfort at all conditions. And so when you're putting in a heat pump, it's covering all the weather conditions. So when it's cold out and when it's hot out. So cooling actually is pretty important. And some of the advances that are allowing heat pumps to be good for heating are also making them better at removing moisture. So, for instance, variable speed is good at assisting in moisture removal. So you have technology that's helping on both sides. And I think that's really important. That will help adoption immensely.
And you bring up a really good point on the heat pump side, because I do think we see a lot of focus on trying to separate latent from sensible loads. And how can we not just cool a whole room down just to get rid of some humidity, but how can we manage both of those loads separately and energy efficiently going forward? So I think there's maybe going to be some more focus in that area as well. And as you said, heat pumps are a perfect way to approach that. Yeah.
I agree. I use the term the judicious use of energy a lot, and it's maybe a bit esoteric, but it means that you want to accomplish something. You want to accomplish a room that's comfortable. Well, you can do that by brute force, and like the way we used to do or still do, dehumidification with reheat and so forth. But that's not judicious. That gets you to where you want to be, but it's not the best use of energy. And I think a lot of the research currently, and where it should go, is toward really understanding, okay, if I have a unit of energy, how do I use that in the most effective way? And things like variable speed and so forth, they are enabling that. They're enabling that to be done much, much more effectively. And the last thing I'll say is that what I do see in the industry is I see a lot of new young innovators coming into this space and sort of thinking this way, like, hey, it's been done this brute force way for 80 years. What can I disrupt about it, or what can I do differently? And they come up with a lot of ideas, and some of them don't work, and that's totally fine. But some of them are, and some of them will.
Perfect note, I think, to end on, although I might have to take you up on the diving deep into the weeds on heat pump designs at a later date. But for now, I think that's it for this episode of EnVisioneering Exchange. I'd like to thank my guest, Ron Domitrovic, a program manager at EPRI, for joining us. Don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever you listen to podcasts. Lastly, if you enjoyed this episode, don't forget to rate, review, and share it with your network. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.